All right, so we're moving to distributing polynomials. Polynomial expressions can often be simplified by distributing a monomial term across the polynomials. Use the multiplication model below to answer A through C. So what I can see here is when I multiply an x and an x, I get an x squared. And then I would also do an x times an x is also an x squared. So I have gone and distributed it to that. Then x times 1 is just simply x, and x times 1 is just simply x. And all I'm doing is I'm multiplying. I can see that that happens more than once here, and I'm distributing that out. And what I can do is I can see that I have 2x squares and I have 8 x's. So when I want to record what it's representing, I have 2 x's right here. So I would write that down, 2 x's, and it's being multiplied, so I'm going to use a parentheses for multiplication, by what we have over here, which is just simply an x plus 4. So that's the exterior part of what it's showing. That's the actual problem. Now, sketch the solution of the algebra tiles. What do I have left? I have 2x squares right here, so I would write 2x squared. And then I have 8 positive x's, so it would be plus an 8x. So if we were to demonstrate how you could simplify the expression using distributive property, I would take my 2x, parentheses, x plus 4, and I would distribute it in. So 2x times x is going to give me 2x squared, and 2x times 4 is going to give me 8x. So it's the same concept. We're applying all of our rules, and then 2x times 4. All right, let's keep going. So what we're going to do is we're going to distributing a monomial across a polynomial can also be demonstrated using area models. We're going to use the model to simplify the given expression. So when I do the math, I would take 6 times negative 3 is going to give me a negative 18, and then x times x, which there's the invisible ones, so that would be x squared. Then you would take 6x times a negative 4. You're going to multiply that 6 and that negative 4, which is a negative 24x. And so that's a negative 18x squared minus 24x, which essentially we're just distributing it in. If I was to draw this next one out, I can see that there are 3 parts to it on the interior. I've got the negative 7 on the exterior right there, and then I'm going to put this one on top. So then we have a negative t squared, 8t, and a negative 2. Negative 7 times a negative 1 essentially is going to give me a positive 7, and then you put your t squared. Negative 7 times 8 is a negative 56, and you bring down that t with it. And negative 7 times a negative 2 is a positive 14, and so that's 7t squared minus 56t plus 14. Each of the models above help to visualize the distributive property, which states that a parentheses b plus c, when I distribute it in, is ab plus ac, because when they're next to each other, it's multiplication. And then I again am distributing in here AB minus AC. When we describe or explain the distributive property, we can say that the term on the outside of the parentheses is multiplied by each term on the inside of the parentheses. All right, so what we're going to do is we're actually going to practice that distributive property. So I'm going to write a little bit more than probably most, but I want to distribute and show what I'm doing. So that's a negative 5b times 15b. Negative 5 times 15 is a negative 75. And then b to the first is a b to the second. Then looking at the next part, that negative 5b times a negative 9. Negative 5 times negative 9 is a positive 45, and that b doesn't have anything to go with, so it's just b to the first. You then combine and put it all together, and you have a negative 75b squared plus 45b. Again, you're distributing to everything. So 4 times 12h squared is going to give you a 48h squared. Then you have a 4 times 7h, which is a positive 28h. You then have a 4 times negative 1, which is a negative 4. And then you also have, right there on the end, a positive 3h squared. So then you combine like terms here and here, and 48h squared plus 3h squared is going to give you a 51h squared, because I did 48 plus 3 is 51, and then the h squared. I then bring down the 28h, and there's nothing to match, so 28h. And then I also bring down that negative 4, so minus 4, because there's nothing to match with it. So you're distributing it in there. All right, let's continue. Miss Peffer asked her students to write expressions that would evaluate to negative 24d squared minus 16d. We're going to circle the names that are correct, so we're going to see if this works and for each one. Negative 8 times negative 3 is a positive 24, and the d's make it a d squared because there's 2 of them. I can already see that Brock is not correct because it's not a negative, and we needed a negative. All right, so looking at Esther, I would do 2d times negative 12d, which would be a negative 24d, so far we're correct. And 2 times negative 8 is a negative 16, and that's a 2d, so 2d times a negative 8 is negative 16d, and that is correct, so Esther is correct. I'm going to distribute in the negative 3d, so negative 3 times 8 is a negative 24, and then that's a d squared. Negative 3 times 2 is a negative 6, and there's a d, so negative 6d. And then minus 10d, we would then combine like terms and get a negative 16d right here, and bring down that negative 24d squared, and that is what she wanted. And then lastly, we have 4 times negative 6 is going to be a negative 24, and that's a d squared. And then 4 times negative 4d is a negative 16d, and that again is what she wanted. So that lets you know that 3 people got it right. Kara simplified 4k plus a half 10k minus 4 as shown below. Describe the mistake and correct it. So we've got our original problem written. We're going to distribute in a half, which means we're going to multiply. It looks like she put the half right here out front, which is not what she should have done. She should have left it as 4k out front, plus a half times 10 is 5k, and a half times negative 4 is a negative 2. We then combine like terms, and 4k plus 5k is 9k minus 2, and we can see she added the half to the front term. All right, we're going to simplify 5g squared minus 3/4 times 24g minus 40 plus 2g squared plus g squared. So we're going to first just bring down that 5g squared. We don't need that again. Then we're going to distribute in a negative 3/4, and that's a negative 3/4 times 24, which is going to give us negative 18g, and then I'm going to distribute in a negative 3/4 again, which is going to give me a positive 30 plus g squared. We're then going to combine our like terms, so 5g squared plus g squared is going to give us 6g squared. I then have nothing to combine with the other two parts right here. So when I rewrite it, it's 6g squared minus 18g plus 30. The last step is always combining those like terms. All right, the height of Martin's rectangular door is 8 inches, or 8 inches more than 3 times the width. So I'm going to write that down that it's 8 inches more. So I'm going to add 8 to 3 times the width, so 3w for the width. If w represents the width of the door, so this is my w right here, what is the area of the door? We would take the w on the exterior and we're going to multiply it because area is length times width, and it's w times 3w plus 8. We're going to distribute in that w, and you get a 3w squared plus 8w. All right, we're going to write an expression to represent the area of the trapezoid. Area of a trapezoid is 1/2 times the height, parentheses, base 1 plus base 2. So when we write this down, we're going to do 1/2 times h. Since h doesn't have a number, we're going to leave h. And then base 1, I always call this one 1, and this one base 2. So that would be 2h minus 8 plus 2h plus 2. We're going to distribute in, so 1/2 times 2 is 1, and then h times h is h squared. Then we have 1/2 times -8, so half of -8 is a -4, and then that has an h next to it. I then have 1/2 times 2 is 1, and it's a positive 1. And then we have 2 h's, so that's h squared. And then 1/2 times 2 is going to be a 1, and it's a positive 1, and then it has an h. Then we're going to combine like terms. So 1h squared plus 1h squared is 2h squared. And a -4 plus a 1 is going to be a -3h. And so 2h squared minus 3h. Science textbooks each weigh 2.5 pounds. Ms. Frizzle has 10 less than twice. So when we have 10 less, we're going to subtract 10 from twice. So 2 times the number of textbooks. And so we'll do 2b for books for right now until I know what to put. The number of textbooks, Ms. Frizzle writes an expression to represent the combined weight, which we have right here. To represent the number of books, simplify the expression. So it actually gave it to us. We're going to start by distributing in the 2.5. So 2.5 times 2 is going to give me 5n. 2.5 times a -10 is -25 plus 2.5n. We then combine like terms, and 5n plus 2.5n is going to give me 7.5n, and then minus 25. All right, if you have any questions, please let me know.